Hi, course 2 students. Today we are on lesson 89, diagonals, interior angles, and exterior angles. Recall that a diagonal of a polygon is a line segment that passes through the polygon between two non-adjacent points. So here we have the diagonal for this polygon ABCD. Diagonal, when we're actually working with these, you can only do it from one vertex. So if I pick vertex A, I would just have one diagonal for this polygon. I couldn't, this is actually a side, so that one doesn't count. And then this is going to be another side, so that one's not going to count. And then I can't just pick another vertex and draw that diagonal. That doesn't work either. So you got to pick it from one vertex and draw as many diagonals as you can that don't touch a side. So this quadrilateral would have one diagonal. And as you see here, it creates two triangles, and that's going to be important for us to understand angle relationships as we look at our lesson. Example 1, from one vertex of regular hexagon ABCDEF, how many diagonals can be drawn? So you see the hexagon here, so they picked vertex A again, and we have 1, 2, 3 diagonals, which creates 1, 2, 3, 4 triangles. Remember that a triangle has 180 degrees in it, no matter what the shape or the size. So I can tell you that the number of degrees in this hexagon is 180 times 4. So I can multiply this. 8 times 4 is 32. 4 plus 3 is 7. So I have, or 4 times 1 is 4 plus 3 is 7. So I have 720 total degrees in all of the angles of this hexagon. You see that depicted here. These are called interior angles because they're on the inside of my shape. We'll talk about exterior angles in a little bit. So if I would add up all of these angles of my hexagon, they're going to equal 720. And if I have a regular polygon, as I have here, remember a regular polygon, all of the angles and the sides are the same. So if I have all of these angles, I know they're all the same, I can take 720 degrees and divide it by 6. And I know that each of these degrees, or each of these angles, is 120 degrees because that's a regular polygon. So you can take your polygon, divide it into the number of triangles, take that number of triangles times 180, and then if it's a regular polygon, divide that total number of degrees by the number of sides of your, or angles in your polygon, and you will know how many degrees one angle is. Let's look at example 2. We're inscribed a regular hexagon in a circle. Find the measure of each angle of the regular hexagon A, B, C, D, E, and F. Okay, so this is similar to what we just did. We know that there are 3 diagonals, which creates 1, 2, 3, 4 triangles. 4 times 180 is 720, divided by my 6 angles in my hexagon gives me 120 degrees in my for each angle of this hexagon. Example 3, draw a quadrilateral on one of its diagonals. What is the sum of the measure of the interior angles of the quadrilateral? So I have 2 angles or triangles here created by my one diagonal. 180 times 2 is 360. And for this one, that's as close as I can get because this is not a regular polygon. So I can't tell you the individual measure of each of these angles. We don't have enough information for that. But I can tell you that the sum of them is 360 degrees because because there's two triangles that make up that, that polygon. Okay, now let's talk about exterior angles. Exterior angles are outside. If I exit a building, I'm going outside of it. So exterior angles are on the outside of the polygon, and they're really an extension of the interior angle. And this is what I mean by that. Go to the bottom of this page. Here's the interior angle that we talked about. If you follow the side over the interior angle outside of it, and then draw a line back to the next side, that's your exterior angle. The exterior angle plus the interior angle is going to be a supplementary relationship. They're going to be equal 180 degrees. So if you know one of them, you just subtract from 180, and that will give you the other. This is another important thing to remember with exterior angles is the sum of all of the exterior angles of a polygon is going to be 360 degrees because you're going all the way around in a circle, basically. Might not be a circle because in this case it's a hexagon, but if I would add up all of these exterior angles, they're going to equal 360 degrees. So if I know that that is 360 degrees and I have 6 of them and it's a regular hexagon, as it is in this case, I could divide 360 by 6 to figure out what one of them is, and it's 60 degrees. So that's what we did for example 4. As I said before, the relationship between an interior angle and an exterior angle is supplementary. So we know that they equal 180 degrees. So if I know the interior angle is 120, or in this case, we knew that the exterior angle was 60, 180 minus 60 gives me 120. So I can figure out the other when I know one of them by subtracting from 180. That is our lesson on diagonals, interior angles, and exterior angles. Let's take a look at our lesson note sheet. This time we're going to be working with a regular octagon. So since it is regular, all of the angles and the sides are the same. There are 3 problems here. I'd like you to do all 3 of them. Not too difficult today. So do draw your triangles on your octagon and or your diagonals to form the triangles, and then you use that information to help answer the questions. Complete those 3 problems on your lesson note sheet, bring them to class, we'll check them over and move on with the rest of our lesson. Have a great day.